When a hurricane forms over the ocean, meteorologists can often predict where it's heading days before it reaches land. But hurricanes don't follow roads or fixed routes. They are massive, constantly changing storms influenced by winds, pressure systems, and ocean conditions. So how do meteorologists know where a hurricane is going? The answer involves satellites in space, aircraft flying into storms, floating ocean sensors, and some of the world's most powerful computers. Let's explore how it all works right here on History of Simple Things. Before meteorologists can predict where a hurricane is going, they first need to know where it is. Decades ago, this was much more difficult. Large portions of the ocean had very little weather monitoring. A storm could grow far from land and remain undetected until ships encountered rough seas or coastal communities noticed worsening weather. Today, satellites have completely transformed hurricane monitoring. Weather satellites orbit Earth continuously, taking images of the atmosphere day and night. From space, meteorologists can observe developing storm systems across entire oceans. These satellites monitor cloud formations, temperatures, moisture levels, and changes in a storm's structure. When forecasters see clusters of thunderstorms organizing over warm tropical waters, they begin watching closely. If the system develops a rotating circulation and continues strengthening, it may eventually become a hurricane. The moment a storm forms, the tracking process begins. Most hurricane tracking starts with satellites. Geostationary satellites remain positioned over the same region of Earth, providing nearly continuous views of developing storms. Meteorologists receive updated images every few minutes, allowing them to watch hurricanes evolve almost in real time. These satellites do far more than capture photographs. Infrared sensors estimate cloud top temperatures. Since taller storm clouds are usually colder, meteorologists can identify the most intense areas of the hurricane. Water vapor imagery reveals moisture patterns around the storm, helping forecasters understand environmental conditions that may influence future movement and strength. By comparing images over time, meteorologists can calculate a hurricane's speed and direction. They can literally watch the storm move across the ocean. But satellites alone cannot provide every answer. For hurricanes that may threaten populated regions, meteorologists often send specialized aircraft directly into the storm. These aircraft are commonly known as hurricane hunters. While it sounds dangerous, the planes are specifically designed for severe weather missions, and their crews undergo extensive training. As they fly through the hurricane, instruments on board measure wind speed, air pressure, temperature, humidity, and other important conditions. One of their most valuable tools is called a drop sonde. A drop sonde is released from the aircraft and falls through the storm while transmitting data back to researchers. During its descent, it records atmospheric conditions at different altitudes. This information helps meteorologists determine the hurricane's exact position and strength, improving forecast accuracy. The oceans themselves provide another important source of information. Weather buoys float in strategic locations around the world, collecting data continuously. They measure wind speed, wave height, air pressure, and sea surface temperature. When a hurricane approaches, these buoys provide real-time observations from directly in the storm's path. Meteorologists compare buoy readings with satellite and aircraft data to build a more complete picture of the hurricane and its surrounding environment. Ships at sea can also contribute weather observations, providing additional information from areas where other measurements may be limited. Together, satellites, aircraft, buoys, and ships create a vast network that helps scientists monitor storms from multiple angles. Knowing where a hurricane is now is only part of the challenge. The bigger question is where it will go next. Many people assume hurricanes move under their own power, but their overall path is largely controlled by larger atmospheric patterns. Think of a hurricane like a leaf floating on a river. The leaf moves because the current carries it along. Hurricanes are often guided by large-scale wind patterns in the atmosphere. Meteorologists carefully study these steering currents. High-pressure systems, low-pressure systems, and jet streams can all influence a hurricane's path. Sometimes these forces push storms steadily westward. Other times, they cause sudden turns toward the north or northeast. Even small changes in these surrounding conditions can significantly affect where a storm ends up several days later. That's one reason hurricane forecasting remains challenging. Once meteorologists gather observational data, they feed it into powerful computer models. These models use mathematical equations to simulate how air, moisture, temperature, and pressure interact throughout the atmosphere. Supercomputers process enormous amounts of information and estimate how conditions may evolve over the coming days. Instead of producing a single forecast, many models generate multiple possible outcomes. Tracking a hurricane involves far more than watching clouds on a weather map. It requires satellites orbiting high above Earth, aircraft flying through intense storms, ocean buoys collecting real-time measurements, and supercomputers analyzing enormous amounts of data. By combining information from all these sources, meteorologists can monitor hurricanes continuously and make increasingly accurate predictions about where they are heading. The next time you see a hurricane forecast on the news, remember that behind those simple lines on a map is an extraordinary network of science, technology, and expertise working together to help keep people informed and safe. And that's how meteorologists actually track the movement of a hurricane. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.